Good morning, everyone. My name is Nishi Das. I will be talking to you about the Atlantis ILIO USX product and the technical details of the product. I also have my colleague, Bharat Nagraj, who is a senior solution architect, and we will be running through a set of agenda items today. If you can see my screen, I will talk about the following agenda items. We'll run through the ILIO USX value proposition, which is the product that we've launched as of February 11th, and we're positioning in the software-defined storage space. I'll talk about different product components which build up the product architecture, essential use cases that actually are relevant for ILIO USX. I'll go into some of the features that make ILIO USX a very interesting product for customers looking at the SDS space. Then Bharat will run us through a demo, which is a demo of ILIO USX on for SQL, as well as show you how IOPS are available on the ADS volumes, which is a component of the ILIO USX product. And we'll close the discussion with our contact information, next steps, and Q&A, for which we'll leave around 15 minutes at the end of the agenda. So with that, I'll jump into the presentation. We're actually extremely happy to announce the ILIO USX product, which is our extension of the ILIO VDI product that has seen great success in the market. The positioning of ILIO USX as a concept is in the software-defined storage space. We've had multiple discussions with a lot of analysts and customers in the market, and we've put in a lot of thought in designing ILIO USX as such. Therefore, I just want to highlight some of the key principles that we've used as we created the product architecture. So if you see the slide that I'm showing right now, there are 5 key principles that we think are key to the definition of software-defined storage. One is abstracting storage, which is the data plane, and delivering data services at the hypervisor layer. And when we say data services, this means a lot of traditional data optimization services that the ILIO core engine has had. This includes deduplication, compression, I/O processing, cloning, fin provisioning, etc. The second concept is about unifying management through the control plane to deliver policy-based performance, availability, and reliability to the upper layer application. There is a management plane that we've created that allows us to manage pools of storage and resource them out to the upper layer application, as you'll see in the architecture. We also try to pool all types of storage infrastructure, irrespective of the storage class and the location. All types of storage resources can be pooled. There's also intelligent optimization of storage done in order to match the performance and capacity requirements for the application. The product also enables on-demand provisioning, and in future it will have the ability to move data between data centers. So these are the key principles of software-defined storage and also of ILIO USX as a SDS solution. If you look at the diagram I'm trying to show right now, USX essentially is a layer that sits on the hypervisor and exposes volumes that are generated from the underlying storage to the upper layer application VMs via NFS and iSCSI. In future, we'll be adding object storage support and CIFS support. And the essential data services like inline deduplication, I/O processing, compression, coalescing, fin provisioning are all made available in the USX code. What essentially we are doing is we are trying to pool the capacity and the I/O that's available across the storage resources connected to multiple servers and create one layer which boosts performance of the application, increases the IOPS, lowers the latency of the external storage, consolidates storage so that the utilization is better, and also allows customers to have a scale-out architecture without sacrificing capacity to get the type of utilization and performance that they need from their infrastructure. That is really the key value proposition of ILIO USX. With that, I do want to give you an overview of the product components. So there are certain building blocks of ILIO USX. The first building block is an aggregator virtual machine, which exposes discrete storage residing on individual hosts. These can be of three types: disk, flash, or memory. What these aggregator VMs do is they in turn create what is called pools, and pools are of two types: capacity and memory pool, and these pools are talking to the individual aggregator nodes and are exposed to the upper layer application-defined storage volume. Application-defined storage volumes are actually talking to the upper layer application VMs via NFS or iSCSI export, and the ADS volumes can be of four types. Hybrid, I'll talk more about what hybrid really is, in-memory, persistent in-memory, and all-flash. And essentially, by the creation of these four types of application-defined storage volumes, the upper layer application VMs get the characteristics of performance, capacity, and reliability that they need in order to make the maximum utilization of storage lying across the data center. A different way of looking at the same concept is we have multiple aggregator nodes that expose discrete resources from different servers. And in this example, I'm showing 6 servers with 6 discrete resources, which can be flash or RAM. And there is some amount of inbuilt protection that we have, primarily because these discrete resources don't come with additional protection. Therefore, we build an inbuilt protection. We actually create an inbuilt protection, and we expose these aggregators to the pools. The pools can also have shared storage, like I just discussed. It can also have DAS, and a combination of these are exposed to the ADS volume. Atlantis ILIO USX also comes with inbuilt HA, and the HA aspects are built into every layer of the architecture. So as you can see, we have HA built onto the pool layer. We also have HA built onto the ADS volume level. And this is an enterprise level HA, which is being provided provided through ILIO USX. This has no reliance on vCenter or any other type of management. In fact, the architecture is very, very hypervisor agnostic and management agnostic. It's also storage class agnostic. The HA model that is being built is an MS-to-N model, which builds redundancy without actually wasting resources. And it also provides users with the flexibility to increase or decrease the amount of HA they add in each layer of the architecture based on the resources that the customer has. And there is a high level of data consistency and integrity that is fully retained in the architecture, both at the pool and the ADS volume level. We have done a lot of testing in our environment on different failover scenarios. In our experience has been that the failover at every level is happening in a matter of seconds or almost minutes. So the HA architecture that we've built allows us to ensure that customers do not waste additional capacity in order to achieve the amount of redundancy that they require for data in their architecture, in their overall data center architecture. So with that, those were the basic components that I wanted to discuss with you. One are the different types of VMs that talk to each other before getting exposed to the application VMs. The second is the inbuilt HA concept, which actually creates strong level of protection. I also mentioned that we have some level of inbuilt protection for the discrete resources because they don't come with hardware level protection. Quickly jumping into the product use cases, there are different software-defined storage models that are available with Atlantis ILIO USX. So if you look at this diagram that is displayed, there are two types of pools that we create from the underlying storage resource. So one is a memory performance pool, which is created from discrete resources like RAM and local flash. The other is the storage capacity pool, which is created by other resources like shared NAS or SAN, flash shared or DAS. And a combination of the two in different combinations are consumed by the application defined volume, which is then exposing itself to the upper layer VMs as an NFS or iSCSI export. There are four types of ADS volume like we discussed in the beginning. The first one is called hybrid storage. And this is essentially memory, in-memory storage optimized for shared and local storage. What that means is you have a combination of storage capacity pool and memory performance pool. And the memory pool is actually being used as a performance accelerator layer for the primary storage capacity pool. And I'll show that in some of the diagrams in the upcoming slides. What in-memory volume layout means is it is a memory performance pool alone without having the storage capacity pool. Persistent in-memory is a model where the memory performance pool is the primary tier and the capacity, there is a small level of persistence built in the architecture with the help of the capacity pool at the back end. All-flash volume layout is a model where flash arrays are consumed as a storage capacity pool and exposed to the application-defined volume. If you look at the diagram here, on the left-hand side, there is a layout, there's a functional layout of the hybrid volume architecture, which is essentially the memory performance pool acting as a performance accelerator for the storage capacity pool. And if you look at the right-hand side diagram, this shows the creation of a memory performance pool from the RAM available across 4 servers. And the capacity pool is created with the help of the DAS in the 4 servers and the shared storage, which is connected to all the 4 servers. And all these, the memory pool here is just accelerating the performance of the storage capacity pool. Memory volume layout is a simple architecture. It's an architecture which is actually primarily used for big data applications, any analytical applications like Hadoop or MongoDB or Cassandra, where the requirement would be more to speed up the performance of the application. There is a small level of redundancy built in here because data is, there's there's rating that's done between the individual hosts, which allows the data to have some level of protection. But primarily the use case is for high performance environments. If you look at persistent in-memory, this model is about creating a shared in-memory pool, which is then replicated to the back end, just to add a small level of persistence to the existing pool, in case customers are worried about persisting the data. This can be an interesting model that keeps the performance high, but then also adds another layer of persistence to the back end. The all-flash module, all-flash volume layout is about using a storage capacity pool primarily to expose the flash pool characteristics to the upper layer application-defined volume. Right. I quickly wanted to run through some of the product features. You'll see the product actually has a simple deployment method. This time we have a fully functional UI. When you first deploy the OVS, the ILIO USX console can be deployed directly onto your existing ESXi host. And you can use vCenter to gather information on the existing resources in your data center. And that includes different hosts, data stores, memory, CPU, networking, all of that. Once the deployment is complete, you will actually see a beautiful screen, which we are very proud of. And this opens up, you can just access the web URL and log into the product with a username and password and enter the management console. There's also easy management that is being built using the UI. It's extremely user-friendly, and you have all the instructions that you need in order to see all the resources that are available and also generate flexible pools out of the existing infrastructure. So if you see the page here, you'll notice that there are layers in the UI. So one is the available resource category. Essentially, if you go into, the first step would be to go into the settings and fill in your VM management details, which could be a vCenter details. Using that, all the information about your data center resources can be extracted and will be available in the available resource section. And from the 3 hosts there, you can then go on to generate aggregators, different types of pools, and eventually different types of ADS volumes. And these ADS volumes can then easily be exposed to the application VMs that are sitting on those individual hosts. So it's a very easy way of deploying the product and also monitoring the overall performance of the product. ILIO USX actually comes with an ability to easily scale. So if you had to add extra servers onto the existing deployment, all you have to do is add the additional server resources onto your existing pools or create new pools out of that. It's as simple as just extending the data service layer, ILIO USX layer, and creating either new pools or adding free resources to existing pools. So you can scale with any type of storage, irrespective of location, by simply adding free resources to existing pools or by creating new pools. And of course, the HA aspect is also flexible, because as you create pools, you can add a level of HA to those by creating HA clusters or by adding new HA nodes to an existing cluster. Another feature of the product is the metrics that we make available in the product. If you look at the diagram here, there are some performance metrics that are made available on disk utilization, CPU utilization, latency, and many others that allow a customer to understand how the overall USX deployment is performing on the free capacity and what is the amount of IOPS, throughput, and capacity saving that's available in the overall environment. There are multiple other metrics that we will make available, and the UI actually allows the customer to have flexibility in terms of customizing what they want to see and how they want to see this information in the dashboard and at what frequency. Also, another aspect of the product, which is the ability to customize monitoring based on APIs. So we have created a REST API service for all the features in the product, and these REST APIs can be customized to work with any existing monitoring tool that a customer may have in their environment. So all we need is to write some scripts that can be customized to the monitoring tools or the upper layer management tier. And we will be publishing all the APIs and very detailed documentation with respect to the APIs, so our customers are able to maximize the utility of the APIs that we make available. So essentially what happens with the product is, with all these features, you're able to create a hyperconverged system. By that, what I mean is you can take all the RAM for the existing servers and create a memory performance accelerator layer. You can also pool the SAS or SATA disk and create capacity pools out of it and generate your own hyperconverged system, which can scale out pretty easily without having to buy any specific infrastructure that has limitations in terms of scale or performance for that matter. It can be done if you want to create your own hybrid SAN or NAS from the existing infrastructure. All you have to do is pool the memory as a performance tier and then pool shared storage and use it as a capacity pool. The flexibility is available in the existing architecture. I'll pass on the ball to Bharat. And Bharat, if you can run us through the demo, that'd be great.
Sure, Nishi. Can make me the presenter.
Yeah, just give me 1 second.
All right. But I'm going to take you through the two pieces of the demo that we have. One, both of them basically showcase the performance of what USX brings to the table. So the first demo is database HammerDB demo, which basically I've built from 4 Supermicro servers using commodity hardware. Using mostly RAM, a small flash array, and a bunch of local disks. What I want to focus on basically is that with USX, customers can be encouraged to build out very high performant virtualization systems. This particular one is in a SQL Server benchmark called HammerDB that's going to run on 4 Supermicros, which is composed of aggregated nodes built from memory, local disks, and a shared storage array. So let me get the test kicking for this. So I'm going to build out a fairly large database, having about 50 users constantly work on that system. So while the database is actually getting built out, what we want to quickly see is the IOPS that the ADS volume can drive. And the SQL Server is basically sitting on top of an ADS volume that's running this. And you notice here that it's running about 1.6 transactions per minute. That you can equate that to about 1.75 million IOPS that this particular system is driving. And remember, this is actually driving from a few memory pools and a few local disks that have been aggregated out of commodity hardware. Such kind of performance, customers usually have to spend millions and millions of dollars on quality flash arrays. So this showcases the actual power of a USX. Let me quickly shift over to the actual UI to quickly show you how it's built out as well. So that SQL Server is actually, okay, let me pop up the UI. So this is how the Atlantis USX, the slides that Nishi showed you, this is what the UI looks like. A few more developments that are happening on the side, but this is the new look UI for the USX. It connects to your virtual center through a settings panel over here, and it gathers up all the free resources in the free hosts area over here. This gives you a list of the ESX hosts available, the data stores available, and the capacity of each, and what type of data stores each of them are. From there, you can build aggregators, you can build memory pools, and you can build capacity pools, and finally build your ADS volumes based on the resources that you have. That SQL Server demo that you were watching is actually being run out of this particular ADS volume. Now, what you want to also notice is it still has the good parts of the inline deduplication and performance optimizations. The performance optimizations was just showed from the transactions per minute demo over there. But you see over here a database of about 1 terabyte size, which is actually shrunk down to about 135 megabytes based on inline deduplication. You get almost close to 80 to 90% deduplication with workloads like this. So the next demo that I'm going to show you is basically showcasing how you can aggregate more and more resources from your backend and drive IOPS purely based on what application requires. So I'm going to launch the iMeter application, and this is the true essence of software-defined storage. You're no longer bound by your hardware limitations, but with USX you can take a very cheap hardware storage or a powerful storage, optimize it efficiently, combine them with your cheaper storage, and build a very, very efficient and performant systems. What I'm going to do is I'm going to run a script over here which is going to dynamically aggregate these USX nodes for me. And these are basically small memory pools built out of those 4 or 5 super microservers I have. And I'm going to basically run a server type workload on about 15 memory pools that I've aggregated out of them. What you want to see over here is I'm actually driving about close to about 1.2 2 million IOs per second. And remember, this is just out of commodity storage that I have, nothing fancy over here. And I can use this ADS volume to drive a particular application that requires so many IOPS. For some reason, if these amount of IOPS is not sufficient, what we can actually do is we can aggregate more nodes, which I will do over here. Aggregate more nodes over here, so I can actually drive maybe 2 or 3 times the IOPS. So you see over here that 1.1 will jump to about 2.6 million IOPS. This is almost unheard of if you think about how you can use software and optimize your memory, the memory resources, your local disk resources, your shared storage resources, combine them to give you a really high-powered system that can almost run any high-intensive application. So that's the demo piece. Nishi, back to you.
Thanks, Bharat. Okay, so hopefully that gave you a good overview of what the product is capable of doing, and also gave you a view of the UI. Some of the UI front pages will change as we bring the product out, but the basic functionalities on the overall pool creation, resource creation is very well defined in the product, and the other features of performance and monitoring are also built into it, as is HA. So with that demo and the overview of the UI, I wanted to run through some of the relevant customer scenarios that may resonate with you and your customers. Some of there are two layers, two buckets in which we are looking at the target customer scenarios. One is general capacity optimization, which is if there are scenarios where there's uneven performance on storage, storage that's not interoperable, if there's uneven performance, or even storage that's interoperable and you want to improve the capacity utilization across that or the amount of performance you get from that storage layer, that can be a relevant use case. This product is useful when there is a increased growth in virtualization, and a lot of vendors are coming out with a scale-out NAS architecture. But ILIO USX can also be used as a way to scale out the storage from existing free resources in case the upper layer VMs require it. There are scenarios where there's a need to have storage consolidation primarily after mergers with different application farms, and that could be a good use case for us. There can be scenarios where HA and DR infrastructure is additionally adding a lot of constraint on the budget, and budgets are primarily focused on applications. There's no budget spending on storage. ILIO USX can be used to actually improve utilization on existing infrastructure, provided some infrastructure is available. And in future, we will also make the product relevant to data center migration use case, which can be a key strategic direction for most customers. The second bucket that we think is important to consider is performance optimization. Some of the examples of applications that are listed here are Microsoft Exchange, SharePoint, database like SQL, big data, batch processing schedules. So primarily from an Exchange and SharePoint application, if you want to increase the number of users that are supported on the current storage, you can use ILIO USX You can also improve the quota size available per user on a mailbox if ILIO USX is actually combined in the infrastructure. From a database standpoint, like Kurt showed, we've done some work on TPCC benchmarks, and there are some impressive results that we've gotten with ILIO USX. From a big data standpoint, our assumption would be that we'd be able to improve the average size of data that is being processed across the nodes, and we would be able to decrease the average time taken for analysis because of the in-memory model that we can incorporate in the existing infrastructure. Also, we are trying to explore some batch processing schedules where hopefully with the help of the in-memory model, we can reduce the time taken to process the batch schedules in case the underlying storage latency is pretty high. So these are some examples of customer scenarios that we are seeing in our customer environments, and examples that we would think are relevant to ILIO USX. And we're definitely open to other use cases that become visible to us through the POC process or through partner POCs that we do as we go through improving the product and making it more relevant and to our customers. So quickly, I just wanted to talk through the product differentiators one more time before we jump into a Q&A session. Essentially, ILIO USX has 3 large areas of differentiation. We provide the storage data services at the hypervisor layer, and that includes our deduplication, compression, I/O processing, and cloning features. We can aggregate across all storage classes, and this includes shared storage, flash, DAS, RAM, and flash array. The target workloads that we are going after are primarily in the server space. A bunch of you asked questions about the VDI workload. Right now, we are trying to keep USX and VDI separate because we want to merge the 2 platforms together in the upcoming 6 to 8 months. But right now, the focus of the workloads that we have in mind is primarily from a server workload standpoint. So in short, ILIO USX is a pure software solution. It covers the entire gamut of storage classes that includes RAM, DAS, SAN, NAS, and flash. USX also provides unique in-memory technology which optimizes data services such as deduplication and compression, like I mentioned before. The product comes with inbuilt HA, which can be extended across the architecture. And there's a large gamut of server applications that we are covering as use cases. Right now, this does not include VDI. The product also flexibly expands the capacity and memory pool. We are working on actually allowing the product to also reduce the size of the pools. And that was another question that I saw. So scaling, resizing in terms of extending the pools and reducing the pools will be possible. Right now we can extend the pools, but we cannot decrease the pools, but it will be possible in the next few weeks. We've already integrated that in the product, and we're just in the testing phase to do that. The important point here is that scale has no hardware restrictions. So I wanted to end with some contact information and resource availability, discussion on the resource availability. So we did a press release announcing the product on Feb 11, 2014. If you go onto our website, you'll find a detailed press release information. Solution brief has been published. We also have business and technical FAQs that have been published. There's also an IDC report on Atlantis ILIO USX, which will give you a view of how the analyst community is looking at us in terms of ACS and the other competitors other competitors in the market. I also want to mention, there was a question I saw. There's a blog and a white paper. There's a white paper, I believe, or a solution brief published on USX with vSAN with the VDI workload, and we have shown. I'll take that back. I don't think we have a white paper, but we have a solution brief and a blog. And I believe Bharat did the testing on that, where we combined vSAN with ILIO USX in order to show a performance enhancement of 4x in terms of IOPS. And the results of that is also published and available for consumption. For any other further information, you can reach me. My email ID is on the slides, and we welcome the opportunity to do as many POCs as we can with our customers. And if there are any partners in this call, then we would benefit from you joining the partner certification program. And for that, if you can reach out to your local sales team, that will be the best venue. Thank you so much. And Bharat and I will take questions, any open questions now. Okay. But did you answer all the questions? I can see that you've answered most of the questions.
Yeah, I think a couple of them. I think the average price of USX.
Okay. Okay, so I'll go through the questions from the top. So James asked a question, you can scale a pool, but can you make it smaller easily? So James, like I mentioned, in the current product, we can only scale the pool. We haven't completed the code for reducing the pool size, but we're already working on it, and in the next couple of weeks, we'll have that, and it shouldn't be a very difficult exercise to achieve. So the version 1.5 release, which is expected in a month and a half, will have that feature. The second question is, the message from a recorded version wasn't clear. Okay, I'm unable to read that question. Do you have an average price for USX? Right now, the pricing for USX is $1 per terabyte pricing. We are discussing the price with our POC customers and trying to figure out what the right number would be, but the number will be discussed with customers, and we'll figure out the right level post a bunch of POCs. All we want to discuss right now is it's on a capacity basis, and going forward with the help of customers, we'll determine the right level of the price. Okay, could USX be used when hosting workloads on infrastructure as a service, or so you need admin access to the hypervisor? Would the IaaS provider have to implement USX instead? So USX will have to be implemented by the IaaS provider. By the service provider, USX will have to be implemented, and the good thing is it's an interesting use case where USX can be used to optimize the service provider infrastructure and reduce the capacity that is really required by the service provider. However, because there's an expansion in the actual capacity provided, the service provider can actually charge their end user at a higher rate because they're able to optimize their overall data center assets better. So to answer your question, yes, the IIS or the service provider will have to implement USX, gain the benefits on capacity optimization and IOPS improvement, and then pass it on to their users or make money out of it. Do you have plans to introduce service provider licensing models? So right now we are going with a base price, which is $1 per terabyte, and going forward, if there is a price that we have in mind, if there are service provider customers and they would like to work with a particular price, we may come up with some bundles in future, but right now it's not part of the plan. Okay, when you say there's also a question, Carrie, this is probably for you. Is there a feature in GoToWebinar to make the specific questions public? I'm not sure how you could make the questions public.
Yeah, I'm messing with it right now, so I'll make those questions that brought answered public for everyone.
Okay, thank you. So when you say SPIS, have you tested or planned to certify for use on vCloud, CloudStack, OpenStack? Good question. So like I mentioned, the product only works with, or rather only depends on having potentially a hypervisor, and it talks to the LUNs, the virtual disk, the data stores exposed through the hypervisor, and there are APIs. So what can be done is you need to expose those APIs to either VCAC or CloudStack or OpenStack in order to orchestrate. That will be a professional services exercise right now. We have just made sure that the REST-based APIs can work with whatever data center orchestrator that is available with the service provider, but we've not done any specific testing there. When we write to ILIO USX, in what moment we get answer about successful write or when file on storage or when file on RAM. Okay, so this varies by the ADS volume that's selected. When we use the hybrid ADS volume, the acknowledgement of the write, the acknowledgement of the read goes back from the buffer, the vScaler layer, and this is actually in a write back mode. With other models, the way the data is being written is based on, it's actually usually in the write-through model, write-through way, where the data is directly written to the capacity pool, except for the hybrid model where it's in a write-back mode. When will USX support replication service, therefore support, for example, dual-side configuration? Replication services are on the roadmap, however, they have not been covered yet. We will be doing a version 1.5 release in a couple of months. I don't believe replication services will be part of it, but I can give you a more informed answer in the next couple of weeks after we finalize the next release cycle. Okay, what will be with data in RAM? If all system emergencies shut down? That's a good question. So we've built in all the redundancies that we can in the architecture. Like I mentioned, we have redundancy builds between the hosts and the redundancy builds on the upper layers in the pools and the volumes. We have not seen any data loss yet, any data that's in RAM and has not yet been written down because of the buffer that is available. But we are extensively testing right now to see if there are any failure scenarios. So I wouldn't know if there is any major data loss, if there is a system emergency shutdown, if the buffer is full and there is some data that's in RAM that has not been written down yet. So to answer your question, we haven't found any data loss scenario yet in the architecture in the testing that we have done, but we'll do some more scale testing in order to see if something goes wrong. In my view, we don't think that there will be any data loss given the buffer size that we have. Bharat, would you have a better idea on that question? Or do you think what I'm saying is relevant?
I think your answer is correct on that one. Yeah, we haven't seen any data loss in the architecture itself.
Thanks. Okay. I'll go to the okay, reading you also, but you answered that question on vSAN, which is good, thank you. All right, I think I got all the questions there. So if there are no other questions, I will close the discussion, but I think I got all the, both Bharat and I got all the 15 or 20 questions there. If there are any more questions, we have 5 more minutes, and I'm happy to take more questions.
If you can just reiterate the vSAN answer to the public audience, I think it will be useful.
Sorry, Bharat, I didn't understand.
The question and answer on the with regards to vSAN, I think if you can just make that publicly aware, it would be good.
Okay, sure. So the question was, reading your reference architecture with USX and vSAN, you got the impression that you also support VDI with USX. But as you told us in the last session, USX is not recommended for VDI now. This gives double messages. What's the truth? How is VDI load licensed? Please emphasize the usage of USX, vSAN, and VDI. Okay, so I guess I'll repeat what Bharat said. Right now, VDI can be used with USX. I mean, maybe some customers will do that. We do not recommend doing that yet, even though vSAN tested it and the results were pretty impressive, primarily because we want to enable VDI use case managed through USX in a different model based on our experience on the VDI workload and what will work best with USX. But that doesn't mean you can't use VDI with USX. We just don't recommend it. I'm guessing in a case-to-case basis, it will become possible to use VDI with the existing architecture of USX. And even then, our pricing will remain the same on VDI. It will continue to be user-based, whereas USX for every other workload will be based on $ per terabyte. So that's an additional answer to what Bharat already mentioned. Okay.
There's one last question. I think Anton was asking whether we have one more webinar with regards to USX. I believe we have one tomorrow at 9 a.m. Pacific, Nishi?
Yeah, so tomorrow 9 a.m. Pacific we have the same presentation, and there were 2 more presentations we did on Wednesday, which is also on the product with a little bit on the use cases and the product features, and that has been uploaded on YouTube as well. Carrie, do you mind sending the link out to probably everybody on this webinar to the other YouTubes as well?
Yes, I can include that in the follow-up email. Also, we will be, within the next 2 weeks, be doing another session on reviewing the vSAN testing and IBM testing. So look out for that in your inbox as well. But this recording, as well as the other two from earlier this week, will be included in the follow-up that you should receive on Monday morning.
Yeah, and I guess if you subscribe to the YouTube videos of Atlantis Computing, you will be able to see all the videos that we put up as follow-up following this launch and these initial YouTube videos. Well, thank you a lot for giving us the opportunity to discuss the positioning of USX. I'll pass the ball on to Carrie now.
Thank you guys for joining us today. As we just restated, the videos will be sent out on Monday. Look out for additional USX sessions, and thank you for your time. Have a good day.
Thanks, Carrie.